So here I have a sketch of two right-angled triangles. Now I want to talk about the three sides in each of them, but each time it will be slightly different because I'm going to, for the first one, I'm going to talk about them relative to this angle here, and for the second one, I'm going to be talking about them relative to this angle there. Now, one thing that's common in both of these right-angled triangles is that this side is opposite the right angle. And again, this side is opposite the right angle. The side that's opposite the right angle is the longest side, and that's called the hypotenuse. Now I need to say what the opposite and adjacent angle are. So opposite and adjacent side, okay, so relative to the angle. So this is the angle, this is the opposite side, and the other side would be the adjacent one because it's next to it. Now here, the angle is here, and this is the opposite side, and this side is adjacent. So notice that it was really the same right angle triangle, but because I had marked the angles in different places, the opposite and adjacent sides had changed. Now I want to introduce some trigonometric functions. So when we have a triangle in this way, where there's an angle marked, and it's a right angle triangle, and I have my sides labeled, there are three functions that will be true for this triangle. Now I'm going to write them down. So we can have the sine function, so sine of this angle, if I was to call it theta like this, so sine of this angle is equal to the opposite side divided by the hypotenuse. Then if I was to say the cos, so cosine or cos of the same angle is going to be adjacent over hypotenuse, and the tangent or tan of the angle is going to be equal to opposite side divided by adjacent side. Now this is in general terms when we're talking about opposite side, adjacent side and hypotenuse. Here I'm going to make it a bit more specific. So I'm going to give myself some numbers to work with. So this side is 3 units long, this is 4, and this is 5. Okay? So this time what I can say is sine of this angle, so sine, this time I'm going to say it's x. Okay, so sine of x is equal to 3 divided by 5. Okay? I can also say that the cos of x is equal to 4 divided by 5, and the tangent or tan of x is equal to 3 over 4. Now I've only talked about what the sine x of this angle is for this triangle, and the cos x and the tan x. Now suppose I wanted to find the value of x. Now the x should be the same in each of them. Okay, so we could use any of these equations to find the x. Now if I use the first one, I have sine of x is equal to 3 over 5. Now if I want to move the sine to this side, what I have to do the inverse of sine. Okay, and we write that like this. So inverse of sine looks like that, and I have to do that to 3 over 5, and this would be the value of x. I could have used the second one, and I could have said x is equal to cos, or inverse of cos, 4 over 5. And if I use the last one, I would have said x is equal to the inverse of tan, and that's to 3 over 4. Now, because I used x for all of them, and I used this triangle, all of these will give me the same answer. And if you put this on your calculator, you press shift and then sign, that will get this up, and you put 3 over 5, you close the bracket and press equals, and the value you will get to 3 significant figures or 1 decimal place, we get 36.9. Okay, the digits on my calculator are 36.869897, and it carries on like that. So I'm rounding it to 3 significant figures, and that's 36.9. It's the same for this one, and it's also the same for this one. Now what I've done here is found the value of x, and my x here was an angle. What I'd like you to do is I'd like you to do all of this process here for this right angle triangle. You will find something quite interesting, okay? And I want you to do that and bring that to the lesson.